that is, you know, just like on your homework, the first thing that you had to do was you had to figure out what the new mean and the new standard deviation was for the sampling distribution. And so it's the same thing here. Write down, I guess there's hardly any room. You can put it at the bottom. The new mean, I'll put it up on the screen so you know what to do. The new mean, new standard deviation for the sampling distribution. So once I get back up there, I will get it up on the screen, but you can really figure it out by looking at this. There you go. I think I've got enough. You need one more. There you are. Make sure you have it up here. Here, I'll just give you that other one just in case. Okay. So give me a sec. I'll get this up here. This is statistics fall quiz. Okay. Okay, so at the bottom here, number 2. Okay, so you could do this like at the bottom where there's that blank space next to all of the Excel junk. You could stick the new, that's all that symbol means, just the new mean, the new standard deviation, and then, I mean, you're going to need to know those anyway to be able to answer these, but that was one of the things you did on your homework. So I like to try to make the quiz look like the homework. Okay. All right, I'm finally done. Hopefully you're closing in on being done. If you are done, feel free to turn your paper over, send it over towards the middle. I'll come get it. So it's premature. Sorry, didn't mean to make you panic. Take your time. Central limit theorem. You as a student. Okay, so you did that. Double check. Let's do, what is today? 25th. Yeah. Yeah, it's there. I'll show you. Maybe you did it and you just don't remember. I'll put it up. It was one of the 2 or 3. Focused on the Excel stuff. Almost done. You're almost done. You can do it. Yes. Let's fill you out there. You can do it. savoring the experience. I guess you got that. That's better enough. All right, you what's that? Who's actually? Marlon said she wanted him. You don't want him? Okay, then please share it with me. What do you got? Almost there? Remember? Okay. See about these guys. Yeah. Yeah. Whatever. We got something. Which one of those is where? Oh, you got those there. That's fine. I'll interpret that. And we got another. All right, good job. All right, I think I got them all. Did anyone else holding out on me, savoring enjoying the experience? All right, staple. Okay, stapling together. Done. Okay, so yeah, well, I don't need to show. I'll just show you the answers to the quiz. Yeah, it seems like part of the homework was dealing with the this thing down here. So the answers here, by the way, is 1,000 is the mean, the new mean. So once you group, so basically if you take all of the apartments in North Carolina, put them into groups of 25, the average of all of the averages of the various groups of 25 should be 1,000, because that's the average of the overall population. The new standard deviation is the old standard deviation divided by the square root of 25, because 25. So it would be 300 over square root of 25, 60. You probably could have figured that out just by looking over here at all those 60s. But yeah, I realized that after I wrote that there. It's like, wait a minute, it's right there. So anyway, here's my answers. So the first one, so you'll notice that there's two distinct types of problems. So I'm going to highlight these. This one is a single apartment. And so that's like what we did before the last test. And this one down here is also a single apartment. So if you're doing individual apartments, you don't use these two numbers down here. So you don't use the new mean, new standard deviation, you use the old ones. And then when you have a group of apartments, when you're doing 25 apartments and averaging them together, then you do this business down here. So that's the contrast. So maybe that's where it was through you that it's like, wait a minute, we're doing both of these things. Yeah, sorry, but we gotta be able to distinguish those two. So getting back to this, with the shading is going to look really similar for all of these well, the two that are the same, like this. The numbers are the same. It's just that the standard deviation is different. This standard deviation is 60. This one is 300. So this is going to be more compact, which means the numbers are further from the middle. This one actually should be even closer together probably. So that's what I got, and I got those numbers directly from my table that I have down here. So norm.dist, it was this number and this number, and I subtracted them to get that. And then the next one, I did the same thing. So it's exactly the same, except for I used the other two numbers, the ones at the very bottom, down here, change shading. So what was it, 800? And this one. And then the other two, it says more than 900. So here's the probability that one apartment, no, this is a group. The probability that a sample of 25 apartments is more than 900. So that you'll use the one where you have the standard deviation of 60, and here it's one apartment. So there, you're going to use the standard deviation 300. So those are my two answers there for those. So let's move on now. So if you did the wrong homework, sorry, not apartment, these are apartments, then maybe go back and do the right one before Monday. So let's move on though to confidence intervals. So we want to have confidence, right? Confidence in ourselves. And we hear about this all the time this season of the year. Every election season, people talk about confidence intervals and margins of error. Here are the three things we're going to do. We're going to deal with point estimates, margins of error, and confidence intervals. We're going to calculate margins of errors. We'll do that actually using Excel because it's a complicated thing to do. And we're also going to calculate a point estimate given a confidence interval. So these are not difficult things. Well, I guess that third one, yeah, we can do. Okay, but before we get started, I have more statistics you can use. And the reason for this is I was looking for something that had confidence intervals in it. You see, every time you look at a statistical paper, whatever field of study you're pursuing, if you look at any paper in your field, maybe not English literature, but almost every other paper, you're going to see statistics. And in those statistics, you'll see one of two things. You will either see confidence intervals or you will see p-values, which represent hypothesis tests, or both. So this one has lots of confidence intervals, so I thought I'd share this. It's kind of interesting. It's also modern. You might think I only have stuff from the early 2000s. Look, this is from 2024. This summer, this came out. How side effects can improve treatment efficacy, a randomized trial by these three people. This is an amazing study that just came out this summer. So 77 healthy participants were made to believe that they would receive fentanyl nasal sprays before receiving thermal pain in a controlled experimental setting. In other words, they were told, we're going to give you a little bit of fentanyl, just a little bit, to see if it helps you with whatever pain you're going to experience. But in reality, they didn't give them fentanyl. Here's what they did. Some of the nasal spray, no fentanyl at all. Some of it had capsaicin, which is pepper, and some of it just was saline, didn't have anything. So you had some people with capsaicin, and some of them, so it would induce a mild burning sensation when it squirted in, just a little bit, not a whole bunch of pepper, they wouldn't sneeze, but enough to cause a little bit of discomfort. And some of it was just plain saline, so it didn't induce any sensation at all. Here's the interesting thing about this. As you can guess, they were testing to see whether or not a little bit of irritation actually improved the pain. It turns out that mild side effects can serve as a signal for effective treatment, thereby influencing treatment expectations and outcomes. So if you have a drug that you're taking for whatever it is, I don't care what it is, if it has some mild side effects, actually it's more effective than a drug that doesn't have mild side effects, at least according to this study. That's just shocking. But here's why I wanted to include this, is because all throughout the paper, they have tons and tons of confidence intervals in their setup. So this is their methodology. They talk about who they used for this study, and notice that they have the age is in a confidence interval. Here's another age in confidence intervals. So you have various confidence intervals. That's what a confidence interval looks like. You have the point estimate, and you have the margin of error. And then this here is the confidence interval. And the way that, oh wait, yeah. I don't know why it's only 18. It should be, yeah, well, yeah, that doesn't make sense. I don't know what that is. But whatever these are, maybe those are the ranges. Maybe those are the ranges of the ages. I don't know. I didn't read it really closely. I was more entertained by the study itself. I love the way biologists do their work, and psychologists as well. At the end, these are in conclusions. In the conclusions, they have now, who knows what these numbers mean? By the way, they actually hooked these people up to MRI machines to see if they were experiencing pain. Because they want to know, does that mild burning effect in the nose actually reduce the amount of pain? And it did. If they had mild burning in their nose, they'd be like, well, I must be getting the real thing. And it actually affected in their brains how much pain they felt. And so here they have various things that they computed, and they have a confidence interval that they've written here. They say it's a 95% confidence interval. Here's another 95% confidence interval. So you have various confidence intervals. These are all the hallmarks of a confidence interval. You always will have some sort of a percentage. You will have the actual interval, like these are the brackets, and then you will have the center. Let's see, there's none of those here. the point estimate, and then the margin of error. So those things, we're going to be doing all four of those today. But there's this. This is just another medical paper that I read about a condition that I have, and we don't need to look at it. Oh, it's coming up. I touched it. I was wondering where it was coming. Yeah, so this is a treatment of restless leg syndrome, and inside you have all sorts of confidence intervals. So you'll see them down here. Confidence interval right there. So throughout the paper. So whenever you read a paper, you're going to see most scientific papers, and by scientific, I mean that broadly. Business, social science, hard sciences, natural sciences. You're going to see education. You're going to see confidence intervals and hypothesis tests. So that's what we're focusing on now that we have gotten through our break and through the basics. So fortunately for us, though, most of this stuff will be done on Excel, but today it's just a setup. So we'll do Excel on Monday, maybe. I don't know. It's a pretty straightforward thing, though. Okay, so here's the actual DICE data, some of it. And so the central limit theorem, this is for the 30. So the central limit theorem says that when you have 30 rolls of the die, you reduce the margin of, or not the margin of error, sorry. You reduce the standard deviation by a factor of the square root of 30. So divide this by the square root of 30. So here is these are the numbers that I actually got from your data over here. And using those numbers, I can actually set up a confidence interval for what the average roll of a die would be. So here's what the confidence interval would look like. Looks like this. And like I said, I'm gonna explain where I get all these numbers in a bit, but I want to just explain what a confidence interval looks like, and then we'll deal with the numbers. Today it's just all about the structure, the numbers, and we'll look at the homework as well. I always will tell you how confident I am. I'm 95% confident that the truth is between 2.9 and 4.1. So I always tell you how confident I am. I always tell you what I am interested in, and I always will tell you the brackets, if you will. Now, Newton does not make you write sentences like this. I will make you write sentences like this on quizzes and tests. However, I will help you to learn the structure of my sentence, and I give you a template. You just fill in the blanks. So when we get to the sentence part, don't fret. It'll be easy. Okay, so let's get to the important stuff, which is where do all these numbers come from over here? So they come from, the first thing is that you take a sample. So we have a sample, and that sample is going to either give me a mean or a proportion. We're just going to have sample means and sample proportions. And this is the easiest thing in the world, that when we talk about point estimates, a point estimate is just the thing that you're using to estimate the truth. So if I were to take the average age of everyone in this room, or all the students in this room, that would be a point estimate for the average age of all students at MVNU. I'm using U to estimate the truth for all of MVNU. So point estimate, average is a point estimate for an average, and P prime is a point estimate for P. So if you want to write anything down, which you don't, I guess you don't have to write anything down, but here's what I would write down. There are way too many words on this slide. I would probably do something like this, is we have a parameter like this. Here, I need to have a blank slide. Here we go, I'll make a table. And you have the parameter, mu, and the point estimate. Is X bar. So this is the population mean, and this is the sample mean. It makes sense that if you want to get an estimate for the population mean, you're going to use a sample mean. I mean, that's why I say this is the easiest thing in the world. This particular aspect of this is if you're going to estimate a proportion, use a proportion. Don't use the standard deviation to estimate a proportion. So for example, proportion, parameter, P, this is the population parameter, or proportion. So I want to know what proportion of MVNU students are planning to vote for Jill Stein for this upcoming election. Then I want to estimate that, so I will take a sample and I will compute the proportion in the sample. And this is the, whoops, not the population, the sample proportion. So that's the first bit, is that you just have to know that if you want to estimate something about a population, you use a similar calculation, a statistic from a sample. And I know that sounds so simple, and it really is that simple. So you're using statistics to do this. Okay, the next thing that you need to know is that a confidence interval is what we make to sort of say, I think that the truth is in this range. So a confidence interval will always be two numbers, or possibly the point estimate plus or minus a margin of error. But you have this range of values here. I'll show you some examples, but you saw some of them on these papers. Let's see, did I have? Oh, I can go back in my PowerPoint, can't I? Give me a sec. So back here, there, yeah, this, you have this plus or minus that. That gives you the two ends of the confidence interval. And then these, you have the confidence interval written as two numbers in a bracket. So what they're saying there, what they're signaling to you, is that they think that the truth is in that range. The truth for what? The truth for the effect on pain relief, whatever that means. So the effect on pain relief is going to be somewhere in that range. So that's what a confidence interval is. It's bracketed two numbers, and it involves a point estimate, which is the middle of the thing, and then the margin of error. Now, we'll be talking about these things in terms of percentages, and that percentage just clues you into the probability that you're right. That's all that is. Like the 95% confidence interval just is saying that I am 95% sure there's a 95% chance that the truth is in that range. And the reason why we can say that is because we know the central limit theorem, and we know how to deal with probabilities in the central limit theorem with normal curves. Here is just a general picture of what's going on, and we'll deal with the mechanics on Monday. But what you're going to be doing is you have some sort of a confidence level. Let's just say that you want to be 95% confident. 95%. Then what's going to happen is you're going to set up your confidence interval so that this picture is true for whatever numbers are here and here using the central limit theorem. So if 95% is there, then 5% would be outside. There's a 5% chance you're wrong. That's why all these presidential election polls, even if they say that it's outside the margin of error, whatever they're trying to show you, and I'll show you some of those. I think I have links here. Yeah, I have some here. Don't worry. There is some chance, 5%. I know it's 1 in 20, but there's a 5% chance that the truth is not in that big blue bubble there. There's a 5% chance that you're somewhere outside. Okay, so moving on. Do I want to do that? Yeah, why not? Okay, yeah, there's a lot of words on this, so bear with me. I'll circle the numbers, though, because that's what really matters. So we're interested in, let's see, what are we interested in? The amount of snow that a certain city receives during the month of April. So, of course, this is probably changing due to climate change, but for now, we could look at historical averages, couldn't we? So to do this, she uses sample data and finds that the mean of the sample data is 26.25, and she computes the margin of error. Notice that I just say that this drops out of the sky into her lap, but she probably used Excel or something to compute the margin of error. We will do this on Monday. Oh, did I mention we're going to do Excel on Monday? Bring your laptops. Go get one out of the library. So take one out of the library to make sure that you can use it. Get one that works. Although I think you might be able to get away with using the online version of Excel for Monday. Yeah, I think you probably can. Just if you, or use your iPad if that's your thing. I think you can, but don't blame me if you can't. But anyway, so let's go ahead and construct this confidence interval. The way I'm going to construct it is I take the point estimate that's in the center, and whoops, 2.5, and I write plus or minus the margin of error. And then I'm going to write this in brackets like this. So the lower limit is what you get when you subtract those two numbers. So I get 20.25 on the bottom end, and at the top end, I get 32.25. By the way, it looks stupid when you put the bigger number first. So just I want to let you know right now off the bat, some of you are going to do this, and I'm going to think, why? Don't put the big number first, put the small number first. So you're going from low to high. I believe that when you do this on Newton, it will not let you put the big number first, which is good. So I think probably the reason why people put the big number first is because the way we say this is we say plus or minus. The plus comes first in our the way we describe that. But anyway, there's my confidence interval. That's it. Okay, so before we do a couple more, we got some more examples, and we're going to take a look at the homework as well. We have some more real-world confidence intervals. Do I have them? I thought I had a link. Maybe is this the link? No, that's not the link. Where are my links? I don't know where my links went. It's okay. I have it pulled up here, so just give me a sec. On here, is this it? Oh yeah, there's a ton of here. So presidential. First of all, the presidential polls. Here we go. Pull this up here. You're probably sick of presidential election stuff. Maybe you don't care. I don't know where you people go to get news. You go to Twitter? Is Twitter a thing anymore? It's not even a thing, is it? What about Snapchat? Is that where you get news? Well, wherever you go to get news, if they've done their job right, they will tell you the whatever it is that you're trying to say. And here I just went and Googled presidential election polls. So they should, and this is probably a problem with those short form videos and short form like things that are like Twitter has so short, or X or whatever they call it these days, that you really can't convey as much information as you should. Let me make this bigger so that we can all enjoy seeing. Maybe here. Let's see. Try again. Oh, there it is. I knew that there was something I could do. Okay, so let's go down and see some of these polls. Why is this not going up? There it is. It's going up. Blah, blah, blah. Lots of polls, lots of pictures, okay, here we go. So Trump 47%, Harris 45% in latest Wall Street Journal poll. But notice that it says that it is within the poll's margin of error of 2.5%. So they tell you the poll, they tell you the margin of error. Ideally, they should tell you what this margin of error means. Is it a 95% margin of error? Is it a 90% margin of error? Or what? They should also tell you the sample size, which they don't do here. But this USA Today is summarizing polls. So, so all they're saying there is that what percentage of people are going to vote for Trump? It's going to be 47% plus or minus 22.5%. So they don't know. And who is going to vote for Harris? 45% plus or minus 2.5%. So that's what that is, the way you should interpret that. And what they're doing here is they're summarizing several polls. I think they did a better job with one of these down here. Here's another one, and then a third one, which has Harris up. Oh, this one I like better because they actually say it's a poll of 1,260 likely voters. So they tell you who they asked, likely voters. They told you when they did this, and then they told you the margin of error, although I still don't know what that margin of error means. But if you don't know, if it doesn't say, usually it's 95%. So 95% is usually what they mean by margin of error in these sorts of things. Let me see if I have anything else entertaining. I might. Give me a sec here. Pull this up. I had a bunch of stuff that I had thought I would show you, and apparently it didn't all show up. Okay, that one's interesting, but it's too complicated to look at right now. What about this one? Oh, that one's really interesting, but I'm not going to show it to you. Okay, so I guess this is good enough. I'll show you some of these next week, I think. They're kind of cool. So that's the idea. When you see confidence intervals out in the wild, you should interpret them appropriately, hopefully. Let's see, estimates. Let's get to the good stuff. Here we go. So some stuff that's similar to your homework, and then I want to pull up the homework and show you the homework because there's one thing or a couple things that are a little bit different than because I can't show you exactly when you'll see. Okay, so suppose you know that a confidence interval for the mean height in inches of a population is 54.2 to 56.4. I want to know the margin of error. All right, how are we going to find the margin of error? Well, bear in mind that this here, that came from somewhere. That came from a point estimate. The point estimate is in the middle of this. So maybe the first thing I should do is figure out the point estimate. The point estimate, x bar, it's actually in the middle, directly between these two numbers. So we could pull out our calculators and just average those two numbers together, and that will give us what the point estimate was, because the point estimate will be equidistant from those two numbers. So let's see, we've got 54.2 and 56.5. I'm just adding them together and then divide, whoops, let me try again, 54.2, sorry. I typed and talked at the same time and made a typo. Okay, and then I'm going to divide that answer by 2. So the middle of that interval is 55.35. So that's the point estimate. That's the middle. Now that you have that middle, you can figure out the margin of error. So if you want to think of this as being on a number line, you have the middle here at 55.35. You have the upper limit, which is 56.5, and the lower limit, which is 54.2. The margin of error will be both of these will be the same. So I don't care which of those gaps you figure out, but pick one of them and subtract the two numbers at either end of them, and you will get the margin of error. And in this case, it's 1.15. So the margin of error is 1.15. So whenever you're asked for margin of error, probably the easiest way to go about it, at least for me, is to come up with the point estimate and then figure out what the margin of error. There is a formula that I could show you, and yeah, okay, I will, only because I know some of you, if you understand this, that's the most important thing in my mind. No, I'm not going to show you the formula. You'll figure out the formula. There's a quicker way of doing this, which you can do, and Newton may reveal that to you, but this you need to understand. And then if you'll figure out what the formula is. It's pretty easy once you realize what's going on here. Let's try another one of these. So let's say that we already did this. So that's the same problem. So if I'm asked for the sample mean, that's the point estimate. So it's the same numbers. The point estimate is that middle number there. So the middle number. All right, let's try another one. In fact, let's give you one to do. Let's start with this. Let's say that we know a confidence interval for a population proportion is this. I want to know the sample proportion. So once again, I'll get you set up, but you go ahead and do this. Maybe I'll go check and see if I've updated my attendance after I draw this. Okay, let me check attendance. That way I can pick randos. I know you're all excited about that. Manage attendance. Someone snuck in. Not you. Evan, you snuck in, didn't you? You're here. Yeah. Excellent. Good job. Okay, so let's see who's got this. I know it's so easy. Where is my randomizer? Random person. Marlon, you know the middle of that, don't you? Wow, 0.37. How did you figure that out so quickly? It's just the average of those two, isn't it? It's the middle. So you just figure out that number by averaging these together. Okay, so we found the sample proportion. Next thing, which I know you probably anticipated, is find the margin of error. So go ahead and do that. It's on the next slide, but I want to keep all the numbers up here. I'll find a volunteer for that. And let's see, preview, I've already done that. All right, Calvin, you know what the margin of error is, don't you?
Yeah, 0.04.
Oh yeah, very good. Sorry, I had the wrong thing in my mind. Very nice. It's 0.04. So it's the distance. You pick either of these intervals. They're going to be the same. So 0.04, 0.04. So the margin of error is 0.04. The way we might summarize this is like this. So you have point estimate, margin of error. All comes together. All right, let's see. So next is the Newton stuff. Let me find, I had it selected and then someone wanted me to look at Newton again and I had to pull up a second Newton. Now I can't find, where's my Newton? Give me a sec. I know I did this. Ah, here it is. There we go. Okay, let me make this big enough so you can see. So, I figured out something about this, that you see the switch topics? So I've been enabling switch topics all along, but unfortunately, if you have subtopics within a specific topic, you can't switch between those. Sadly, I wish you could, but it won't let you. Let me make this a little bit smaller. Wait, that's big. Small, small, small. There it is. Okay, so this is the sort of thing. We just did this. So you've got your confidence interval, and they even tell you the sample proportion. You can easily find the margin of error now, I'm pretty sure. Oh, they use, okay, sorry, I had a different symbol. So sample proportion, they're putting a little hat on top of the P. So you see that upside down V. So just so you know, that's the sample proportion. So margin of error is simple. The thing that I wanted to look at here is, let's see, so here are all the topics: understand and compare, confidence intervals in context, calculate a point estimate. Okay, all of these things. Wait, where is the one? Maybe it's this one. Can I switch to this? Start? There it is, start. Yeah, so apparently I can't switch to different subtopics, but I can switch between the major topics. So let's do this one and see how this works, because this, see, you've got a nice picture. Oh, I love it. So let's just take a look at this briefly to see how this works. It says that we have a population standard deviation of 0.3, unknown population mean, random sample of 37 4-year-old girls, and then the mean, whatever, the mean of these was 8. I want to find a 95% confidence interval. So you might say, well, we didn't do any of these calculations yet. Yeah, we haven't, but all this is clicking and dragging just to give you some experience for seeing visually what a confidence interval looks like. Let's take a look at this one, and then I think we'll be all done. Give me a sec. So you'll notice that you have this stuff here. Wow, it's so much. Just a minute. I need to, okay, so it says the random sample is 37. So that is in. That's the number in the sample. So let's go down and put that down here. In is 37. There, 37. Give me a sec. It says that the sample mean is 8. So that's X bar. Where is X bar? Right here. Okay, X bar is 8. So move this over to 8. Good enough. Then it says that we want to find a standard deviation is 0.3. We'll be talking more about all of this, but all of these are ingredients for a confidence interval. So if I want to make a confidence interval, I need to know the sample mean. I need to know a standard deviation of one sort or another. I need to know the sample size. These are all ingredients And I also need to know how confident I want to be. I don't know why anyone would want to be 50% confident. 90% is something I've seen, but this particular problem is saying 95%. 95% confident right there. Once you have all of that stuff figured out, it shows you this beautiful normal curve that illustrates what a confidence interval is. So the middle is here. You can see the lower and upper limits to my confidence interval. But what a confidence interval represents is this area where there's a 95% chance, and you can see that big bulge there. There's a 95% chance that the truth is in that range. Now, technically, the idea behind a confidence interval would be that there's a 95% chance that my statistic is within the margin of error of the truth. Which I know it sounds like the same thing, but technically it's not exactly the same thing. But we can still use this as an illustration of, so this isn't quite right mathematically, but I don't care. It's close enough. So you have this 95% bulge. There is a small chance that that the truth is out there or out there. So a little bit bigger or a little smaller than the confidence interval. But 95% chance that we're right. Once you've done all this, which you're just going to click and drag all this junk, all you have to do is copy these numbers. What does it say? Round to 2 decimal places. So just copy those 2 red numbers down. If you've slid the sliders correctly, the rest is pretty easy, 7.90. And then this number is 8. Looks like I'm going to have to round to 10 because it doesn't want 2 digits after the decimal place. Let's see if it likes me. I'm pretty sure it does. I could always cheat, but I'm not going to this time. Yay, I got it right. So you'll want to do something very similar with your confidence intervals. Well, in the 5 minutes we have left, I need to mention something. On the syllabus, you'll notice it says something about projects. And you might be like, wait, maybe you've completely forgotten that from the syllabus. But we're finally to the point where we can do some projects. So next week, I will bring project number 1 to you, and I'll just give you a quick preview. What you're going to do is you're going to use some real data to make some confidence intervals. That's it. And we'll talk about it more next week. And I will make sure you have that data that you can use. So I think that's it. Stick around if you have questions. Maybe you want to complain more about, oh, if you did not pick up your exam last time, I forgot to bring it. My apologies. So I'll bring it on Monday, hopefully.